Hi, everyone. We're going to get started. Today we have a really great presentation that I think is going to be really beneficial to everyone who's maybe new to using the Workbench or has been in the Workbench for a while and wants to use some of the new data sets. So Francis will be talking about 6 keys to having an optimized workflow in the Workbench. So I'm going to turn it over to Francis. You can feel free to put questions into the chat, and we also will take questions at the end of the presentation as well.
Thank you, Melissa, and welcome everyone, and thank you so much for coming. Yes, as Melissa said, I'm going to talk about 6 keys to having an optimized workflow in the Workbench. If at any time you want to ask a question about what I just said, or you want me to repeat something I just said, don't hesitate to cut me off and or raise your hand, and I can just go over it. I try to talk as slow as possible, but just don't hesitate to cut me off whenever you need me to go over something. So I am going to work in from the Workbench directly. I don't have any PowerPoint points, but everything is going to be in here. And this is from the stable environment. Does everybody see my screen?
Yes.
Okay. This is from the stable environment, so the data is fake. Don't worry if you see something strange or in the data, so because it's not the real data. As you can see here, it's a stable environment. You don't have this if you have the reproduction. As we said earlier, we're going to talk a little bit about optimized workflow in the Workbench. We're going to touch on a lot of stuff, reading the data, working with the data, saving your work. And the reason for that is because one of the main reasons why we use Notebook and having all of these tools is because we want to foster collaboration and reproducibility. So everything that we created, the engineers created, the tools that we have are always centered around those 2 key items and other things. So I just want to show you and go over a little bit of some of the best practices that you can include in your daily workflow to help you during your analysis, make your analysis not better, but in a sense, but maybe faster, or so that you don't have any issues with working with the tools. I'm going to do this presentation in Python. I will try to point out whenever there is a difference, but I didn't include anything that's particular to Python, but I'll point out whenever there is a difference between R and Python, but there shouldn't be. And so first of all, I just want to say that the Notebook is a great way for reproducibility and collaboration because you can share the Notebook with your coworkers or analysts that you work with. And as you can see, for example, we can have titles and we can have lists and we can have the code, we can have output and we can have text in there. So you have your markdowns. So it's a great way to just add notes to your code instead of having just plain codes. But the first thing I want to talk about is to use our tools and take advantage of them. And specifically the cohort builder and dataset builder, because sometimes we have questions that we don't know how to code them. For example, let's say we have questions about how do I get age? And that's when it's really important to go and use the tools like the code builder, because it can give you the code, for instance, on how to just do that. So if you go back to your workspace and let's say you go to cohorts to build your cohort and you do add criteria and age, and you can see in here that you can check like age at consent or current age and age at CDR date. I just want to point out that if you are working from the registered tier, the dates are shifted, so you don't get the current age or the real age at consent. The age at consent is correct, but the current age is more or less correct, but there is a few because of the date shift. And if we have calculate the age at today, we don't get exactly the real age. But and same thing for age at CDR. But here, for example, if you want to find how to calculate age at consent, you can just take this and create a cohort, and finally, once you create your cohort, you can just name it consent cohort. And then once you get that, you go create the data set. And in creating your data set, you can go here, select the cohorts that you just did. And that can show you, let's just say we're just gonna take the demographics. And that should show you how to calculate age at consent. So basically, there are many things that we might not know how to code, and it's better to use these tools were created just for that purpose. And if we go and see code preview, for example, and then we can see that how we can get the age at consent by looking at this code, and we can reproduce that and change to whatever we need. Same thing if we need some concepts that we don't know what they are, but we know that they are, for example, in conditions, then you can go here and you can just type, let's say diabetes, and you can search, and you can go over here and see what are all the diabetes, and these concepts, those are what we have in the data. So you can just go one by one and you can see what you need. So these are what you can use. That's what I meant by don't forget to use the tools whenever you need something that you might not know yet how to do it, because most of the time it can be at least an easier version of it can be found from the tools, and you can use that and you can add to that. So always check first in the tool whenever you want to ask some questions. Try to build the cohort and see the code that's going to be output and work from there. So that's one of the key things. And for working with the data, reading the data if you don't know. And the second key is to make your query a little bit optimized, and this is for reading data. And there are a few things that I want to talk about. And the first of all is that BigQuery is really fast. So most of the time you don't need to worry about these things, but you can always make your query better optimized, and by optimizing your query also, you reduce the cost that you pay to query the data. Even if BigQuery is not expensive, it's still good to always reduce cost, because you have to remember that if you are the owner of this workspace and you share this with other people and other people are going to work from this, they are going to spend your free credit, not their free credit, but your free credit. So that's why it's a little bit better to optimize your query so that the more money you save, and the better. So the first thing is to avoid using the select star. I'm sure a lot of people won't mind using those, and adding limit, for example, in here to get just first 5 or of the data. But BigQuery doesn't work that way. So basically what this is doing, if you do select star, this is saying to BigQuery that go through all the columns, so and just output the five rows. So you pay the cost of querying from all the columns that exist in the person table. So instead of that, if you know exactly what columns you want to query from, it's better to specify the columns. And so in here, I specify person ID, the sex at birth, and race. So in here, the cost of this, and even if I put this one, the cost for this query is gonna be smaller than this one, because this is gonna process all the columns, whereas this one is going to process only 3 columns. Even if this gets all the rows and this just output gives you one random row. But if you don't know, maybe you don't know what columns you want to take or to look at in the table, and I invite you to go and look into the wiki of OMAP. If we open this, it has all the almost all the tables that we have in the data set. And here, for example, you have the list of the tables, and we have the person table, the visit occurrence, that's where the visits are, the drug exposure, the procedural occurrence, device exposure, measurements, observation, and death. Those are the most important tables and the tables that you probably would need when in your analysis. And so, for example, if you want what's in the person table and click on the person, and if you go here, and you'll see that you would have the person ID, the gender, concept ID, the birth, month of birth, day of birth, birthday, date, time, race, concept ID, and so on. And from here, you can say, okay, I just need the ethnicity concept ID. I just need the race concept ID. And as you can see, it's all, most of them are in concept IDs. Those are the, in OMAP, everything is related to concepts. So the concept IDs are what you need, and those are just numbers. They are not user-friendly, but they're just numbers, integers, most of the time. And they're numbers to just to denote something. But whenever you need, for example, if you need to know what exactly is sex at birth concept ID, you have to join that to the concept table. So for example, we need, for example, this what is the user-friendly display for this sex at birth concept ID. So that is going to be in the concept table. So you have to join the concept table. So let's say we want the race and sex at birth in here. So we need to join one of them is joining the concept table with let's name this sex at birth. So the concept ID in here, we join it with the sex at birth concept ID. And from the concept table, so instead of from the concept table, we can get what's called concept name. And that is gonna be the user-friendly display for the sex at birth. And same thing, if we need one more, so we need to join the race. If we need the race concept IDs, we need the race, the user-friendly display for the race. You again need to join the concept table once again. So I'll just copy and paste. And in this case, so remember, you can see here that I have an alias for this as S and this one as R. So here I use the concept ID from the R and I join it with the race concept ID. And I can use again from R, I can use again the concept name, and that should give me the race. So those are the best way, instead of having this select star that most of the time you should avoid. Always specify the columns that you need. And if you need, if it is ending with concept IDs, then you can join whatever that column is to the concept ID in the concept table, and you can put the concept name in here, and that's how you get the user-friendly field corresponding to that to whatever you need, whatever is ending in concept IDs. And another thing to optimize your query is whenever you need to do summary statistics, if the end goal is to have summary statistics at the end, like count or mean, max, average, it's better to do them in BigQuery than doing them in Python, because that will save you some memory. So for example, let's say that I wanted to list the race. So one way of doing this is, okay, I list all the person ID and the race in the person table, and then I just count how many of those are, how many races for each the occurrence. So I'm just gonna count here the occurrence of each race category. You can do that, but that will raise the F in here. As you can see, this variable is gonna have a long list of all the person IDs and their race. But if the end goal is just to have this particular table, it's better to right away do that from BigQuery, because that will save you some space. So in here, for example, I just directly count the race from BigQuery itself, and that's what I get as an output. And in that, you save computing time, because this will run fast, and it will save you also memory in here, so for your other computations. So that's another thing that I would suggest. And another thing that I can suggest to make your query, to make your query a little bit optimized, is also to add and smaller in size, to add filters whenever possible. So, for example, in here, let's say we want to find the COP May survey data for a particular cohort. So one way might be, okay, I'm just gonna pull all the surveys. This may crash your notebook because the survey is huge. So I wouldn't recommend this, because this just saying, okay, just give me all the surveys. Instead of that, I would say, okay, in the survey, just add more filters. Let's just get May. And even if, for example, you just need one specific question, add again that specific question filter. So as much as possible, always do most of filtering or calculations in BigQuery. If you don't need, I mean, of course, if that's the only thing that you need, but if that's not what you need, if you need to do something else, then it's okay. But most of the time, you have some specific cohort. For example, you just have some person ID that you're interested in, so you can add the person ID in, and then you list your person ID in here, 634, and so on. So as much as possible, always add filters and just get whatever you need, so that you don't have, like, for example, in here, you just gonna have a big data frame that you might not necessarily need, because you only need a very specific cohort and a very specific survey data. So those are what I recommend, what I found in when I review some notebooks. These are things that can help people. So that's what I have for our number 2, which is write an optimized query and optimize the BigQuery reading, when reading data from BigQuery. The next thing that can help you, then key number 3, is to save data from super long query. So let's say that you used a very long query. It took some time to run it, but the data is not super huge. And here I'm just saying as an example that this might be just data that you get, but your query was super long and it took a little bit of while to get it. So when instead of rerunning that query next time, you can save that intermediate data somewhere, or the input data somewhere. And in this case, it's in the bucket. You want to save that in the bucket, so that later on, instead of rerunning the query again, you just read from the bucket. So here, I'm just gonna show you how to do that. So let's say, for example, this is the data frame that you have. And so what you need to do is save this in the bucket. In R, it's the same step as well. Just whatever you see in here, as a Python, it's just going to be replaced by R. So we're going to use the code snippets. And basically inside this, if you go in the menu snippets, and all of us Python and cloud storage snippets, in R, it's all of us R and cloud storage snippets. You can say copy file to and from bucket. So you have this copy data to workspace bucket. So this will copy your data to the bucket. And the bucket, think of the bucket as your disk hard drive, where you can save things permanently. Things that are saved locally in this workspace is not, but if you want things to be saved forever until you delete them, you have to save them in the bucket. So if we read through this, two things. First, One is that it always assumes that you run setup first. So if you go back to snippets and close storage and setup, you need to run that first. It's always better to run that first. And then the other thing is, we need to only replace whatever is above this. We try to add this don't change from here so that it's automatic, but we can change whatever is in here. So my data frame is taking the name of the data frame that you saved, and the file name, this is how you want to name your file in the bucket. So let's just say state lists and you can run this, and this will save your data in the bucket. Now that while it's running, and so, okay, so now it's saved in the bucket. So you can check whether it's there or not. So you can go again back to snippets and list objects. So if you go in here and you run this should list all the objects in your bucket. So as you can see inside data, we have our state list.csv. So that's what we need. The bucket has the notebook, of course, all the notebooks that you have in your workspace, but most importantly, it's whatever is in this data. So next time, so now that we know that it's in the bucket, we can get rid of this. And what we want to add is how to load that back into our workspace. So you go back to the snippets, all of us cloud storage, and copy file to, and then instead of to, now you're doing copy file from workspace bucket. And so if you're here and you didn't know what was the list, what was the name of your file, so that's why you can use, that's how you can use this list object. And when you run this and you say, okay, I don't remember what the name is. Oh, it's state list. So you just change this. So state list. That's CSV, and you can run this. So now, okay, so here we have our my data frame. We put it in my data frame, but we can put it back into DF. So we can say DF my data frame copy or something, or you can use that, and now you can have it back. So instead of reading, let's say you had some query in here to get this data frame instead of this data. Instead of rerun, you can get rid of that query, or you can comment that out so that you won't be run. And so you can get rid of that and just use this, and you can get back your data frame so that you don't have to rerun that long query, and instead reading from the bucket directly. The same thing can be used if you want whatever you save, if you're saving your final data or any other intermediate data. You always need to use that snippets. Remember, if you didn't use that snippets and copy file to the workspace bucket, if you didn't use that, then whatever you upload in the local workspace, they are automatically deleted after a certain period of time. I think it's after a week or so. So it's not gonna stay inside here forever. You have to always save things in the bucket if you want those data or those files to stay permanently or until you delete them. So that's that part. So always, if you have a long query that you run, instead of rerunning those queries, you can save the intermediate data or save the data that you need in the bucket and just load those from the bucket and reuse them. So that's a super life-changing cost saving as well. You don't have to run that long, or time saving for you. And if all else fails, I guess most shouldn't be, but if you still need more power, so you can just increase the computing power of your default instance. So that's our key number 4, and you can do that by yourself. You don't have to contact us. You just go to on the right hand side, you have this Thunder Cloud thing icon, and you can click on there, and it will pull up this. And there are a lot of things in here, a lot of information, but most importantly, so it will tell you how much it's costing you per hour And it's also showing you the remaining free credits that you have. So you start with $300 or so, and then this is what I have left to spend. So here you can increase your CPUs or your RAM. If you say like, oh, I don't have enough, I think I need more, then you can increase this up to 32. And you see, if let's say I increase to 16, so now it's $20 per hour. But so you pay more if you increase your computing power. So that's just what I want you to remember. So the more, whatever the configuration, if you need more, you're just going to pay more. That's all. So yeah, you can adjust this if you need. Most of the time you don't, but if there is a need to adjust them, you can increase your CPU, you can increase your RAM, and that should make things a little bit easier. So that's, at least those are key number 1 and key number 4. So those are really working, reading the data and saving the data. Those are helping you to optimize when you read data, or when you work, to make it work a little bit faster, to save you some time. That's what keys 1 to 4 are about. Let me recap a little bit. And so first of all, don't forget to use our tools, the code builder, especially if you want to ask some questions like how to code some stuff that you don't know. Sometimes the answer can be in the tool, so don't hesitate to use that. Write optimized query in terms of, especially add more filters if you need them, and do your calculations from BigQuery. And this is important, especially doing the calculation from BigQuery if you are working on Fitbit data. Fitbit data is a little bit huge, so it's always better if you need to do summary statistics or you just need counts, you do that directly from BigQuery. BigQuery can handle them. Your notebook might crash. Then add filters. And then another thing is save data from, if you have a query that's taking forever to run, so it's better to save those intermediate data or input data in the bucket first and loading from the bucket. And then one thing is to increase your computing power if all else failed. So that's the last resort. Maybe you just need to increase a little bit your CPU or your RAM. We'll pause a little bit because I don't know if there are questions or comments on what I said before I keep on going.
I think it's going well, Francis. We've gotten a couple of questions in the chat, but we've been able to point to resources for everyone. One question though about maybe just the concept set selector and how comprehensive it is. I tried to answer for Jay, but it's a fairly comprehensive search. But if you wanted to really drill down into like breast carcinoma or something really specific, we can also search by those keywords, correct? So you don't get everything.
Yes, that's correct, yes.
And then what if you have trouble finding concepts in Athena? Is it possible that there are some that just don't, that won't show up in our search?
Yes, that's totally possible. So one thing to remember is that those are not everything from Athena. Those are the concepts that we have in the data. So there may be some concepts that exist in Athena, but if we don't have it in there, so that means that we don't have data for those. So that's just a nuance. But as long as it exists in the data, the concept should be there.
And just a reminder, we are recording this session and we will post it in the User Support Hub, and we've included the link a couple of times to the chat, and we'll include it again at the end.
All right, so if we don't have any other questions, I'll keep on. So key number 5 is restart and run all. So this is something that I would recommend, especially if you work from notebook, because It's crucial for reproducibility and to get rid of errors. Because what happens in the notebook is this doesn't, if you, within this session, there is no kind of like sequence. So for example, I can do this. Let's say I create this data in here, and I can go in this particular cell here, which is above this, and I can just call this test in here, and it will run from this session. It will run. But next time, if somebody is rerunning this, you won't. And I think there are times where, oh, we just need something real quick, and we are using some variables that we created below, and we reuse it up, but we cannot do that later on. So it's always better to have this whenever you're finished, to restart and run all, so that you make sure that everything runs from the beginning to the end. So basically, this is kind of like your check to make sure that things run smooth and there is no error. If you start everything from the beginning, this will execute the cells in sequence. So now that if you run this, for example, there will be an error in here because it's saying, oh yeah, you reference to a variable that you haven't created yet. So to do that, you go to kernel, and there is this restart and run all. So you can just hit that. If you want to run the cell one by one yourself, you can just hit restart and go from the top and keep hitting Control and Enter. But if you don't want to do that, just go to kernel, menu kernel, and restart and run all. That was run everything from beginning. And in this instance, if we run this, there will be an error in here saying that, oh, you're using something that's not referenced anywhere. So that's important. I think it's really important to do that check because of just the what notebooks allow us to do. It's important to check that we are able to rerun everything from the beginning without any error. And the last key is to save your most recent working version of the most recent working version of your notebook. So because you collaborate with other people, and people might change your code or whatever, and there is no way, because we don't have there is no way to do some versioning with notebooks, and so if people change if people that you give the permission to edit change your notebooks and change some codes in here, then you won't be able to know what they changed, and you won't be able to see what they changed, and you cannot revert back to whatever you had before, or at least the working, because let's say that they messed up one of the code and now the code is not running anymore. So you won't be able to revert back unless you save the most recent working version. So we created a code snippet for that, where you can, it doesn't have the full power of Git. If anyone is familiar with Git, it doesn't have that full power, but at least it's saving your notebook, and you can just compare and go through whatever you changed and see what happened. So let's say, for example, I added something in here, and let's say this is the code change that I did, and let's do one thing first. Let's save this. So if you go to snippets and you go to all of us Python cloud storage snippets, because the saving is going to be on the bucket. This last interact with last code snippet interact with HTML snapshots in the Workspace bucket. You can click on that. So put your, let's say, select this cell, go back there, click on that. That should just create, give this code, and you can run this. And it's showing you this nice UI. So in this UI, in create, you are going to specify what you're going to save. So the workspace, if you go back, the workspace is named tests. So okay, so I will find in here, and here I want to point out that unfortunately you have to do this from an from a Python notebook. There is no corresponding R code for this one. So if you are working from an R notebook, you need to open, create a new Python notebook and work from Python, because the advantage of using this is that this can save any workspace. This can just go through any workspace, and you don't have to be in the, let's say, in test to save test. Because here, for example, I can see my all other workspaces, but here we are interested in test, and we are interested in saving our notebook office hour optimization. So I select that, and you need to add a meaningful comment in here just to tell you that what is your save path. So for example, here, let's say that this was what we did here was adding the first model. So we can say add first working model, and you can be as specific as you want. It's saving our notebook, but you want this code doesn't have we don't have a code snippets in corresponding work notebook. So let me tell you what, let me show you, for example, let's say go in here. So you can see this is an R version, the R version of that particular works notebook. So this is a notebook, it's an R, so it's saving it, but you cannot run this code from an R notebook. That's just what I mean. So that's what I mean by you have to open a Python notebook, and that's only where you can use this code. This code is not written in R. So that's just the reason, but it can save our notebook, and you can save Python notebook. So we are interested in office hour optimization. So let's say we're saying adding first working linear regression model. That's what we did. That's not what we did, but always add meaningful comments and you submit it. And this, there will be something that's gonna run. So, all right, so one thing to know whether it's, and so now, all right, so one thing to know whether it's finished or not is this. If you see this is right now, it's like this. So that means that it's finished, that nothing is running. If something is running, let's say we do it again, second version, I'm submit. This will turn into this black dot. So as long as this is the black dot, so that means something is running. So we'll just wait until this is turning into that gray, and there you go. So now it's finished. So let's say that, okay, now you logged out and somebody else came in and they changed your code. So instead of this, they just named this test and they saved it. You come back and it's not running anymore for some reason. And it's not running, and you can see exactly that the error is in here in this particular line. So what you do is you go back again to that if you don't have this yet. So you go back again to the snippet and this one, and you run it. And once you have the UI, now instead of create, you go into view one, and in view one, you can specify the workspace. So our workspace is again tests, and choose whatever we need. So we were doing the office hour optimization, so we can select. So that's the only thing we have in here so far. So okay, so you can view the comment, for example. So we have second version. We should have. Let's see. Let's view all. If we view all the tests. So retrieving 2 comments. So you can see here, so we have one is in this particular time frame. That's one, and this is the second version. So we would need this. So 1842.06. So if we go back to view one, so instead of this, we choose the other one, 1842.06, that you can see in here. 18. So this is what we need, the first working linear regression model. And we notice that the date is 2021-05-28, and the time is 1842.06. So we choose that. And then you can see, view the HTML snapshot. This will run and retrieve the notebook and will display it in here. So now that you have this, you can locate where is, so let's say, oh, this was the things that changed, and I go back, oh, and you can see here, oh, this is what I have, and you can just copy that and you go and replace your whatever was not working with this. So now you have again your working version. So that's the only thing that we found that can help you restore your code, because there is no Git versioning system that can work with. But you can use this to locate, once you locate your error, and go back and see when the last time you saved it, what was there, and replace whatever the code was, the error. So those are the 6 keys that can help you. I don't know if you have any questions, but that's all I have for today. So you can now start asking your questions, or if there is no question, but other questions not related to this, you can also ask them.
Francis, we do have a question from one of our researchers, Colby. He is interested in understanding the population demographics of the 192,000 participants who have EHR data. So he's just wanting to know what the best way to pull down the demographic information for all participants in that cohort. Oops, you're muted.
All right, so sorry about that. So the first thing is you need to pull let's say you need to pull the person ID for those 190 participants. Let's see if I have. It's not in here. 1 second. Let me just give an example of that. Okay, so in here, I'm just gonna put this in the chat. Where is the chat? So here there's some gist on how you can get some of the participants. So for example, if I'm looking at the participants with EHR data, so I can get that query from the link that I just sent. So for example, this is the query that gives you those participants. Basically, these queries taking all the people in measurement, condition, device exposure, drug exposure, observation, procedure, visit occurrence. And the EHR data is, you specify that the source is this EHR site, and it has some numbers, arbitrary numbers. And what I'm doing here is I would change this a little bit to get all the person IDs of these people. And once I do that, once I have that, so in this EHR, let's just say EHR PIDs as person IDs. So once we have this data, and then we can go and so I can just say EHR PIDs list. Well, so this is for Python, and I would do the similar thing for R. So what you do is you would just say, so in EHR PIDs, the F person ID, because remember we collect the person IDs, the column. So in this will give you the list of the person IDs from this. So the EHR, the person ID with EHR data. So what you do is to get, I name it list. So it's a list right now. But what you do is you want to turn it into what's called the tuple, and I'll show you why that makes things easier. So you add tuple in here, and basically what that is doing is kind of, you're gonna have something like this in the end. You have the parentheses and you have the list of IDs. So this will give you something like this. And now that you have that, you can get the demographics. So you write another query for the demographics. And let's say for the sake of time, we just say, okay, so you get the person ID and you get just race. Let's just say we just take the concept IDs and from person, then you add where, so your person ID, you only want the person ID in this particular, so here you can add the EHR PIDs, for example. So now that you have that, what I put in here, so you can see I add curly brackets. So the curly brackets, it will tell this query that these might be variable that you're gonna change somewhere. So when you get the demographics data, so you would say, okay, query, and this format will tell in here, you specify, so what is the data set? So for example, in data set, let's say the data set name is a call registered here. Actually, let me tell you how to do this. So basically, this is also another good thing that you should always try to do, because when we change a data set, this will change automatically. So for example, we had a data set just released. We had one released earlier in 2019, and then we released another one from 2020. So whenever there is a new registered tier data set, if you type the name of the data set in here, instead of doing this, you're just gonna have to change everything everywhere that is mentioned when we change data set, when you move to the other data set. If you do this, put a variable name and instead get the data set name somewhere from this OS, and you can specify this workspace CDR, that will give you the name of the data set that is attached to this particular workspace. So even if you migrate to a new data set, this will change automatically. So in this case, now you just specify, okay, the data set is going to be the data set name, and the EHR PIDs is going to be this one that you just get. So that will give you the demographic, at least in this instance, is the race of everybody who has EHR data.
Thank you. Yeah, it was me who asked. So thanks. And just to be clear, the data set in the top query that you're pulling, the longer query, this is just pointing to that same one that's attached.
Yes.
That data set is really everything, right?
Yes. So okay. This again is changed to into data set name. So
okay. Sounds good. Thank you. And
so basically, you have to run this at the top. But yes.
Could you try putting that link for the large SQL query in the chat again? I can't see it.
Catherine, I see your hand is raised. Did you want to ask a question?
Yeah, sure. Thank you. Thank you, Francis, for taking the time to do this for us. My question, I want to go back to this idea of saving our notebooks, and I'm just trying to think through it. So if I have my notebook in R, if I went up to the snippets, I wouldn't see any snippet about saving, correct? Okay.
Yes, you won't have, you can, so basically you cannot run this code from an R notebook, but you can save your R notebook.
So how would I open, so I guess I don't understand the next step. Like if I wanted to save my R notebook, do I open a new Python notebook?
Yes. So for example, you go back to notebooks.
Mm-hmm.
And so let's say, let's assume this is an R notebook. So you go back to notebooks, to your notebooks by clicking here. And then in here, you create another notebook in Python.
Okay.
And just name that saving, and you have to make sure that it's Python. And you create a notebook and it's running. And once you're here, let's say this is just meant for saving your R notebook. So you can just go into the snippets and class storage, and here, there you go. Let me show you the difference, because if you're in R notebook, you won't be able to see that.
Right.
Say,
well, isn't my code's in my R notebook? So if I'm opening a new Python notebook, how will that Python notebook find what to save?
Oh, so you just find everything that's in the that's currently saved wherever. For example, in here, as you can see in here, I can even go to some other workspace. This is test, but I can go to this particular how to get registered with registered tier data workspace.
Oh,
right?
great. So,
yes, and you pull me the notebooks that's in there. This is not even related to this workspace at all.
Got it.
Yes.
Okay,
so
that's
go
helpful.
Anywhere. Yes.
Thank you.
You're welcome.
Okay, I have another question from B. B, you may need to unmute and help me out here, but she's trying to find she's trying to compute the time between the diagnosis of sleep apnea and the diagnosis of hypertension, but she can't find a fitting code in Athena. So that was her first question. And then she's also wondering how to request a date for diagnosis, and then also how to deal with the different participants having different diagnostic criteria. So diagnosed with benign hypertension or general hypertension, but wanting to collapse across all hypertension criteria if possible. It's a lot of questions.
So the first question was, she cannot find the concept related to the condition she's interested in, right?
Correct. Yes, in Athena.
Yeah. That I guess you have to talk to your principal investigator or somebody or a clinical person to ask them in general what ICD-10 or things like that people would use, or SNOMED code people would use for the particular conditions, because it's that's hard, which that I don't know, so I have the answer to the question.
Yeah, thank you, Francis. I do have the codes for the conditions I want, but what I'm missing is the date they were diagnosed with. The date of diagnosis of these conditions, because we're interested in computing the difference between, so basically we want to know what came first, sleep apnea or hypertension. And so we want to know like what the time difference between these diagnoses is. And I can't find any criteria that, or like any kind of variables or concepts that would, link the date.
So, I see. The date is actually in the condition table, the date is in condition start date. So let's see condition occurrence.
Oh.
So if you look at, so here we go. So the condition start date, this has the date that you are looking for. So you add this column, and this will give you the date when they were diagnosed.
Oh, perfect. Thank you so much. Yeah, I looked in Athena. I didn't look right there, and I couldn't find anything there. Thank you so much. Yeah, that's super helpful.
Yes, so Athena has only concepts, so anything related to concepts, let's say, for example, if you have a concept IDs and you want to know what it is, or you want to know its ancestors or its descendants or things like that, so that's Athena. Now, when it comes to the data where you want to know what kind of field I want to ask if I need this particular data, so you have to refer to the OMAP. This OMAP, if I haven't put this yet, you have to go back there and check within a particular table, like what the fields are. And
thank you so much.
You're so welcome.
That is super helpful. And then, I saw in one of your tutorials how to compute age, so I think that shouldn't be too difficult to compute the difference. But so how do I deal with the fact that, so, there are, for example, 5 different criteria I have for hypertension. So, there's benign hypertension, there's just general hypertension, there's, like a couple of different ones of those. So how do I deal with that? Is there a solution for those kind of things?
So what do you mean dealing with that?
So if I want to compute, I basically have that kind of splits my whole sample into several different subsamples, right? But I want to have that date difference for all subjects that are categorized as having hypertension. So do I have to compute this date difference separately for, let's say, benign hypertension, general hypertension, whatever other kind of types? Or can I just list all of them and then it computes this for all of the subjects?
So you want to find the difference between dates of 2 conditions.
Mm-hmm.
So that can get a little bit complicated because what if the person has, let's say, the same condition but at 2 different dates, and then.
Right.
But I think yes, you still can. So what you want to do is, I mean, you can create a bigger table where, let's say, you have all the benign, you said, I think, and one category of, let's say you have everything about one category or one type of hypertension in one table.
Yeah.
And then get another table for another category of hypertension. And you can create a full join or an outer join of the 2 tables that will create all the pairs for each, you join by person, all the pairs of possible things that you want. I mean, all the pairs of date combinations for each of these 2. I don't know if that makes sense.
It does make sense. Whether I'm able to do it or not, I don't know yet.
Yeah. So instead of, let's say, for example, here, let's say we have a DF1 is where we have that first category of hypertension. DF2 is the second category. So what we'll do is something like, let's say, I'll just say DF, but you have to name it, you give a meaningful name. Don't do 1 and 2.
Okay.
Give a meaningful name, but you would say, let's say DF1 and merge it with DF2, and you would say how is outer and on, so they need to be merged on person ID. So this will create for each person ID in here. So for each, let's say each row in here, combine that with all the rows for each row for each person ID in here.
Okay.
Cross join so that you have like all the different combinations of all the data in here for each person in here. I don't know if that makes sense.
Okay. Yeah, I'm so new to all of this that this is my first task. So it's probably not the easiest thing to start with, but yeah, I'd love to give it a shot.
Yes. Okay.
Thank you so much, Francis. That's great.
You're welcome.
Thank you, everyone. We have reached the end of our time. Francis, we do have another question from a user, but I wanted to acknowledge that it is past 2 o'clock. So do you have time to take one more question, Francis, or did?
Sure,
okay.
yes.
All right. We just have one question from, let me see, I go back, from Mina regarding, she's having trouble deciding how to interpret roll-up counts versus item counts. And then, let me see, she had another one, sorry.
What was the first count, Melissa?
She wanted to know the difference or how to interpret the roll-up count versus the item count. And then she wants to know if she should choose standard concepts or combination of standard and source concepts within the hierarchy.
Item counts versus row counts, right?
Yes.
Yes. Okay, so item count can be row counts. So the thing is that each table in here except person table. So each table, let's say if you look at conditions, Beatrix mentioned the conditions. For example, one person can have multiple, they went to the doctor multiple times and diagnosed with the hypertension disease. And so each time you go to the doctor, you have a row in the condition table. So then one person can have multiple rows. So if you count rows, then you get all the instances for that particular conditions. But let's say if you count person ID, distinct person ID, then you just say, okay, how many people just have that? How many unique people? So I think that's where the difference is. I don't know if that is that answer.
Yeah. Thank you, Francis. I was talking about, so I was looking to include PTSD, post-traumatic stress disorder, and gave a search for that term. And the concepts that were pulled up were like 3 different concepts, slightly different in their spellings and the way there was a hyphen between post-traumatic or not. And they all had, so there is a column for item count and a column for roll-up count. And so, not necessarily for this concept, for other concepts too, there are, 2 distinct columns. And I was trying to count how they both associated in terms of whether they kind of added up somehow. And so I was having trouble trying to decide which concepts to choose from my data set and which to drop based on whether they were counted in the aggregate count somehow. If you have an office hour where I can show you exactly what I was having trouble with, I would love to show you that. And the other thing was I was having trouble selecting concepts based on standard versus the source concept ID. I was trying to look at the hierarchy of the source, like SNOMED for some conditions, and the ICD codes and how they fall in the hierarchy, where they fall and what are they including. And I was having a hard time picking which ones to pick and which ones to lose, to drop from the ultimate data set. So I guess, I'm a researcher, I'm not a provider. So having a provider kind of tell you how to pick and not to pick, is that the route to go, or are all the source concepts included in the standard, mapped to the standard concept ID?
Yes, I think the best way to choose concepts is having a clinical person tell you exactly which ones you should use and which ones you should throw. Otherwise, the best way is just, if you don't have anyone, you can't find anyone, is to just specify maybe in your paper or in your research that these were the concepts that you use. But preferably, it's better to have a clinical person confirm that these are really the concepts that are associated with the conditions that you're looking at. For the first question that you had, yes, I think it would be better if you send us an email to our research support team, and maybe add some screenshot, as long as it doesn't contain some data or anything. That would be great, so that we may be able to assist you more, because seeing what exactly you see would help us a lot.
Thank you, Francis. We are going to come to an end today, but I did want to put out information. Our next office hours will be on June 11th, and Kayla Marginian, one of our all of us staff members, is going to be talking about our data curation pipeline and the difference between the data browser and the researcher workbench data sets. And I think that would be really beneficial to understand kind of globally where and how we get our data. So if you're interested, that is June 11th at 1 p.m. Central. I'll be sure to send out that invitation the week prior. But thank you so much to everyone. Thank you to Francis. Thank you for all your questions. This recording will be posted again on the User Support Hub in the Community Forum section. And if you have any questions for the help desk after, feel free to either email support@allofusresearch.org, or you can submit a help desk ticket through the User Support Hub. Thank you, everyone. Have a good holiday weekend.